Hi, my name's Trevor. I'm the author of Lamorna Engine, a light 3D game engine featuring a software renderer which you just saw running. Today I'd like to talk about the engine's sound system. Lamorna Engine features a sound engine that handles basic 2-channel spatial audio with multiple sound sources mixed into a local buffer and streamed to direct sound. The sound system is composed of a number of elements. A WAV sound file. These contain the raw sample data. I target the sound files used by the original Quake game, which are 8-bit 11 kHz WAV files. This is a low quality, low bitrate format, but proves adequate for my needs. This is the data structure that I use to store the WAV files based off the WAV file spec. We have some header data that describes the file, things like the number of samples per second, number of bits per sample, and back in the main structure we have the number of samples present and then the actual sample data itself. The samples are stored in a single channel 8-bit unsigned integer format, but I convert to stereo 32-bit floating point for sound mixing and playback. The next structure to consider is the sound trigger list, which contains a list of sound events initiated in the current frame. The list starts empty each frame, and we pass the entity component system for entities with a sound component and check for sound events, usually triggered by state changes. We also check the collision system output for collision events that emit sounds not associated with entities such as projectile impact. Each sound source is given a unique ID relating to its origin, a WAV file associated with the sound, and the sound source position. So triggered sounds are added to the active sound list each frame. Let's look at the active sound list. And this contains a list of all current sounds playing. Newly triggered sounds are added to the playlist, and sounds that have finished playing are removed. An active sound entry contains an index into its source WAV file, current play cursor, source ID, left and right volume values, a flag indicating if the sound is to be looped, and the sound position. The list is maintained by having an array of active sound structures with indices of those in use and those available. Now, we also have a local mixing buffer. The engine maintains its own mixing buffer, which it writes down to the direct sound buffer when mixing is done. The active sound list is processed each frame, and sufficient samples generated to fill a local buffer. This buffer inherits its format from the direct sound interface structure initialized above it, and is of sufficient size to hold a frame's worth of samples. This is the direct sound interface structure, and in this structure we define the format of our play buffer, maintain a pointer to the direct sound interface and a pointer to the direct sound internal buffer. This buffer is the final destination for our sound samples and must be kept supplied for smooth sound delivery. Its operations are handled by the operating system and are fairly opaque, save for a play and write cursor whose positions can be queried. The buffer must be unlocked and then locked following write operations. Let's look at the initialization of the sound system. This first section of code deals with creating and initializing our direct sound interface and play buffer by filling out a series of buffer descriptors. Next, we initialize our active sound structure. Note that it contains some constants relating to sound attenuation we'll have a look at further down. We add a sound file to the active sound list, an ambient background sound, just to kick things off. We clear out our local mixing buffer and then start the direct sound buffer playing. Now we turn to the code that handles the processing of the sounds each frame. So we'll just skip this section of code here and move to looking at the handling of the sounds in the active sound list. So here we add any sounds triggered during the frame to our active sound list. And note that here is the this section. We remove any sounds that have finished playing from the active sound list, and here is where we add any sounds triggered during the frame to the active sound list. Note that the ID of incoming sound triggers are checked, and should a new sound match one currently playing, the sound is simply restarted. Next we come to sound attenuation. This is done 4 sounds at a time in SIMD, so some broadcasting here into the vector registers and initialization. The source position of each active sound is transformed into camera space, and left and right volume values computed based on orientation, and attenuated by distance into a linear soundscape with a near and far plane for clean sound cutoff. And the output of this block of code is a new volume level for the 2 channels for each active sound relative to the player position for this frame. Sounds marked as ambient are excluded from spatial computations. Now we come to generate the sound samples for our current frame. As mentioned before, the WAV data is 8-bit mono, so stepping through each active sound we convert to 32-bit stereo, attenuate with the volume levels computed earlier, and sum it into our local buffer, clamping to prevent overflow. This is all done with SIMD, processing 4 samples at a time. Now, before looking at this final section, we need to talk about filling the direct sound buffer. Possibly the most difficult aspect of creating a sound system is properly filling the direct sound buffer. That is, determining how many samples to write at a time and how often. I understand a common method is to fill the buffer a certain amount, then initiate a callback for when the buffer needs refilling, but I take a different approach. I write to the direct sound buffer each frame and oversupply by a conservative amount. In the following frame, I check how many samples have actually been consumed by querying the direct sound play cursor, and advance my active sound cursors by that amount. I consider this a simpler approach, and by oversupplying slightly, you cover any irregularities caused by system lag, albeit at a slightly higher processing cost. Here in my local buffer, I have written down as many samples as I consider a slight oversupply. And then returning briefly to the top of the processing block, we can see this first section of code that we skipped is about stepping each active sound play cursor forward after querying the position of the direct sound cursor. So now, as a final step, we can write down the contents of the mixing buffer to the direct sound buffer, locking it prior to the write and then unlocking it when done, and writing with the awareness that it is a circular buffer and we might need to write to 2 sections. Well, that concludes our look at the sound system. Be sure to check out my code reviews of other engine systems, visit my website, and follow me on Twitter. Thanks for watching.